Programming and languages. The very first step in programming in terms of software development. So this is our first step in software development. And our book actually used SDLC, Software Development Lifecycle, while other books reserve SDLC for the System Development Lifecycle. Just an FYI. So the very first step in software development is what's known as program specification. This is where we have the programs, or listed out are the program objectives, but the objectives are basically the problems that we're trying to solve. In the program specification stage, we also determine the desired outputs. In other words, what is it that we're going to get out from the computer system? The next step is input data. Once you know the output you want, you can determine the input data and the source of this data. The processing requirements, which defines the processing tasks that must happen for input data to be processed into output. And of course, along the way, you want to document these steps. The next step of the software development lifecycle is program design. In program design, you have what's known as top-down program design. And in top-down program design identifies the program's processing steps. These steps are known as program modules, where each module is made up of logical related program statements. And this is one of the techniques used in program design. Another technique under program design is what's known as pseudocode. And this is where you outline the logic of the program that you would write in text. For instance, set total regular hours and total overtime hours to 0, get time in, get time out for a job, etc. We also use flowcharts. Flowcharts are graphical presentations that detail the sequence of steps needed to solve a programming problem. Flowcharts typically express all the logic for just one module that we determined back here in the top-down design, or in the top-down program design area. A lot of times within a flowchart, you'll also have what are known as logic structures. This is how we link the various parts of a flowchart. There are several different types of logic structures. The first is what's known as sequential. In other words, we have one statement which then flows to another statement, which then flows to another statement. There's also selection, where we can have if a certain condition is met, and that's a yes, then a certain statement will occur. If it's a no, then a different statement will occur. And then we also have what's known as repetition. That's where we have perhaps here a do while loop. If yes on a certain condition, then we have a statement, which then comes back, and then of course no here. So while a certain condition exists, it'll keep doing something, such as in your typical, for those of you who coded before, you'll have perhaps a loop run to where 1 plus 1 is added several times until it reaches perhaps 100 times to add 100 different numbers inputted by an individual. So and it could be n plus plus or something like that at the end, to where if it was at 0, it'll be at 1, and then it'll be at 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Next, we have what's known as program code. So after we've done specification and gone down to design, we're now at program code, which is what we all see and typically think of when we think of writing or programming a particular system. And under program code, we have a term here called structured programming. And structured programming is basically using the logic structures that we've talked about, okay, and writing them in, or actually all of this, and writing it in a programming language, okay, because all of this is structured. We do that using what's known as a programming language. The programming languages have evolved over the years from what's known as machine language, also known as first generation language. These are the languages that typically come in ones and zeros that machines understand, but we don't. We have to memorize what these combinations do when we are doing programming in such a way. So therefore we created assembly languages, which are also known as second generation languages, and these assembly languages use abbreviations like add, okay, maybe subtract, or other mnemonics that are automatically converted to the appropriate sequences of ones and zeros. Next, we have what's known as high-level procedural languages, third generation languages. These are languages that are closer to what we understand. And in these languages, we have to, because they're English-like, convert it to these ones and zeros that you see here. And therefore, you'll need either what's known as a compiler or an interpreter to do so. Next, we have what's known as task-oriented languages, or what's known as fourth generation languages. Fourth generation languages are non-procedural and focus on specifying the specific task the program is to accomplish. Examples would be SQL, okay, or an application generator that we'll use in databases this semester. And finally, we have what's known as problem and constraint languages, fifth generation languages. Fifth generation languages incorporate the concepts of artificial intelligence to allow a person to provide a system with a problem and some constraints and then request a solution. Those are the languages that we're headed towards, or that is the language that we're headed towards, fifth generation. But right now we're at third and fourth. After you've written your program, we need to test the program. And that's what debugging is. We're trying to eliminate errors. There are two types of errors. There's what's known as syntax errors. Syntax errors is a violation of the rules of the programming language. You know, kind of like spelling add. I don't know, like that by accident, adding an E or something. All right, those are your syntax errors. And then you also have your logic errors. Logic errors occurs when a programmer uses an incorrect calculation or leaves out a programming procedure. In other words, if you were trying to calculate a salary where you have base and then you have a tip, right? If you're if you did retail or if you were a waiter or something like that, a service industry individual, so your total salary would be base plus tip, but you said minus by accident. Okay, that would be a logic error. It would still compile. You wouldn't find any syntax errors, but you would have what's known as a logic error. How do you find these errors? The very first step that you can take is what's known as desk checking. That's where you actually literally proofread the code and look at it. And then another way is through manually testing the sample data. That's where you're using a calculator with sample data and following the statements to be sure that it's calculating what it's supposed to be calculating. Another is what's known as attempt at translation. This is where you actually use a translator program where the translator attempts to translate the written program from the programming language into machine language, and thus you know for sure that you'll be free of syntax errors. And then there's testing sample data on the computer, okay, where you're actually testing for what we talked about earlier, logic errors. Okay, so you're using the computer and using data to ensure that you get the total that you want. And in here you'll find, whoa, my total is less the tip amount rather than plus the tip amount. And then finally, testing by a select group of potential users. In other words, you want to be sure that those particular users actually get to try it out and provide feedback to you to get a flavor of, is it doing what it's supposed to be doing? So after we've tested the program, we then go into program documentation, which is simple as it is. In program documentation, we need to be sure that the documentation has actually been done throughout the entire process so far, so that it's documented in a manner so that the users, operators, and programmers know how it all works. And it is tailored to these particular end users, that you have that documentation that's tailored to each of those individuals. And then of course with that proper documentation, we then go into program maintenance, where program maintenance spends approximately 75%, okay, of the entire cost of the program is all under maintaining the program rather than just developing it. Okay. What are some of the things that are there? Well, obviously you have your patches, okay, basically corrections. You know, if you had that base plus tip, okay, if it was a minus by accident and it wasn't caught in testing, all right, then you'll put the plus sign back or something like that. A lot of times the errors could happen in repetitions. It could be so-called one-off, either over or under for those of you who have programmed in the past. And that could be fixed. If there's significance, number of patches, a lot of times we refer to that as a software update. All right. Under program maintenance, we also have the term what's known as agile development. And rather than going through this entire software development lifecycle in the manner that we did with agile development, we go through all of that by doing it in a manner where we don't have all the requirements yet, so that we produce a deliverable, and with that deliverable being able to be shaped in a format that we want through iterations. That's agile development, meaning that we can get something done and produced faster. So today we talked about programming in languages, starting out with program specifications. Basically, what are the objectives of the program? What is it supposed to do for us? Now that we know what it's supposed to do for us, where are we getting the data from, etc., we're going to start designing it. Okay, not necessarily programming it, but planning it out, writing out the blueprint of our program via top-down programming design, pseudocode flowcharts, which include logic structures. Once we have our blueprint, then we actually get into the coding. Remember, these are structured programs because of our logic structures, etc. And we choose the programming language that we want. Once we've done that and done our programming, we then test it. Basically, we're just debugging it. And these are the methods of debugging it to find these particular types of errors, syntax or logic. And we must be sure that we have been documenting it the entire time to specific individuals, or better said, that we're documenting it through different individuals, but specifically to different individuals, meaning that perhaps we're documenting it not more general, but geared towards different individuals who will use it differently. And then finally, we maintain it through patches, updates, and of course we added one extra term here, agile development, allowing us to do all this at a faster pace by starting out with less requirements, basically gathering less data and waiting for everything to come in. Rather than doing that, we start out faster. And that is programming in languages.